Welcome to QCC's Face the Region. Face the Region is produced by Quinsigamond Community College to assist our region in attaining educational, economic, and personal prosperity. Good afternoon once again, and welcome to QCC's Face the Region here on Full Service Radio, AM 830 WCRN. I'm Zip Zipfel, and today we're at the QCC Fab Lab in the new Quest Center on the QCC campus, talking with Damian Kieran, who's the Associate Professor of Manufacturing Technology. Damian, good to have you on the show. How you doing?
I'm good. I'm glad to be here.
We're back in classes. You got a whole new bunch of kids?
Yes, the wave has hit.
There you go. So the Fab Lab, that's an acronym for something, is it not?
Yes, it's a digital fabrication lab.
Okay, and that was the Fab Lab, I believe that was the brainchild, at least the name, from Gail Carberry, the departed former QCC president?
Yes, and it's really a movement that came out of MIT, and there are equivalent Fab Labs all over the world. I think there's about 500 of them now.
Right.
So it's really a movement.
Cool. So so tell me a bit about the whole program. Sort of give me an umbrella overview, if you could, of the program.
So at QCC we have a manufacturing program. And within that, we have some certificate programs, some associate degree programs. And recently, with investment and this new Quest Center and the new Advanced Manufacturing Center, we've really added a lot of state-of-the-art facilities to support the manufacturing program. And the Fab Lab is a piece of that.
Right, and in the background, I don't know if you can hear that on the audio, but I guess, is that a digital printer that's currently working a project?
That's a MakerBot 3D printer that's running behind us.
And that is a high-end 3D printer?
That is, it's not the highest end. It's a workhorse model of 3D printer. We have some more expensive printers, which we'll talk about in a little while. But that's kind of the workhorse in this lab. You know,
I would hazard to guess, at least from my particular perspective, that this type of course, does it fill up pretty quick? I would imagine you've got a full house in there.
We are one of the fastest growing programs in the college. We're still relatively small compared to some of the other ones. And so we have room to grow, but we're growing pretty fast.
And again, a student coming into the program, tell me a bit about what he would learn here and the type of fields that he could apply, the disciplines that he acquires here.
So we're really trying to produce two kinds of people. One is somebody who can go straight into industry, and that's primarily what we're doing. So if somebody comes out of here with an associate's degree or a certificate, they can go work in industry as a technician. So they would be setting up machines, repairing machines when they break down, setting up for new products, all the work that a technician in a high-tech industry would do.
So are we talking about IT, or is that just one aspect of it?
It's really not IT. It's really the programming of machines to create whatever the products are that the company creates, and then the support and the maintenance of all that equipment.
Right. So give me an example of what a typical aspect of that would be. In other words, programming a certain, just a basic thumbnail.
Our students could be involved in the design of products because we teach them how to do 2D and 3D design. But more likely they would be involved in taking a design that somebody has created and then creating the program code, the machine code, to actually make that part on a machine. So for example, a metal part that's cut out on a milling machine, we teach the students how to actually write the code that tells the machine what to do to make the part.
Now that's a fairly advanced kind of discipline, is it not?
It is, and it's probably more complicated than it seems. So we can take students in who really have no experience in this area, and in a couple of years we can turn out experts in the area.
What would a potential student coming into the program, what would be helpful for that student to have studied prior to coming into the course?
A fairly solid base in math and science is good. Obviously math helps in any kind of technical area. If they've been exposed to some computer-aided design or something like that in high school, that would be even better, but not necessary.
Right. When you say computer-aided design, CAD programs, that industry is just exploding as far as job opportunities, is it not?
Absolutely. The feedback we're getting from our local employers is in the areas of CAD design and in the areas of CNC programming and just general manufacturing technicians, they can't hire enough people.
Right. And when you say CNC, that's an acronym for
That's
computer?
numerical control. You really think about, big machines cutting metal, right? And the CNC piece of it is what we teach students to program here.
So often I think the perception of manufacturing, people kind of think of a non-air conditioned place in a loading dock and a lot of dirt and big open fire pits and things like that. That's pretty far from the norm these days.
We're trying to change that perception, and some people even think the name manufacturing conjures up that idea. But I think if we can get some people to come in here and see what we're doing and see the kinds of equipment that we have, and maybe also visit some of the local companies, they'll have a totally different perception of what manufacturing is.
Right. Say, for instance, you've got a non-traditional student, which QCC obviously caters to in many cases. Maybe it's a guy that's worked in a more traditional analog machine shop, drill press, jig type lathe operation. Is there a future for him to jump into this type of field?
Absolutely, and that experience in the area of machines will be helpful to them. But we can help that person come in at ground level in terms of what we're trying to do, and in a certificate program or an associate's degree, really give them the expertise that they need to work in high-tech manufacturing.
And again, so it's not just, push these 3 buttons in a row. It's more of like really getting into the actual design and implementation of the program.
Right, and it's actually creating the program that tells the machine what to do.
Right. Important slot, I'm sure,
Absolutely.
in a lot of companies.
Absolutely.
We're chatting with Damian Kieran, who's the Associate Professor of Manufacturing Technology here in the Fab Lab, and it is a fabulous place indeed, on the campus of QCC in the Quest Center. We'll continue to find out more about the opportunities in such a place when QCC's Face the Region continues in a couple of minutes on Full Service Radio, AM 830 WCRN. Welcome back to QCC's Face the Region here on Full Service Radio, AM 830 WCRN. Zip Zipfel along today with Damian Kieran, who's the Associate Professor of Manufacturing Technology right here in the Quest Center, the brand new Quest Center on the campus of QCC, and surrounded by some high-tech gear, which we'll find out more about in just a couple of minutes. But Damian, in our first segment, we talked quite a bit about the certificate programs, which is a 2-year program, right?
We have a certificate program which can be done in 1 year, and then an associate's degree, which is a 2-year program, if done full-time.
Right, and now the associate's degree, does that set you up for a 4-year school?
That sets you up either to go into industry or to move on to a 4-year degree, and we have some articulation agreements that makes that process easier for students.
Right. It's kind of funny, too, and talking to the various professors in all the departments, everybody throws the term articulation agreement around. Explain that to the layman.
That just makes the process by which the students get credit for the work done here at the college that they're going, the 4-year college that they're going into. So, for example, for us, we have a specific agreement with Fitchburg State. So our students with the associate's degree get 2 full years of credit going into the Fitchburg State program.
Okay, so a 4-year, what would it end up being? What would those 4-year programs be?
So that would be a bachelor's program.
A bachelor's degree, okay.
The one at Fitchburg is specifically called Industrial Technology, I believe.
Right, and that, again, that's sort of a just basic training in all of these disciplines, and
yeah, that just puts the student at a whole other level and probably increases their earning potential lifetime. But again, that's not the primary goal for us. The primary goal for us is to turn out people who can support our local manufacturers.
Right. So what are we looking at here? I know 3D printers, am I correct in that?
Yeah, so this is our bank of MakerBot 3D printers. We have 4 in total. And as you can see, these machines are kept busy pretty much all the time. Students use these machines on a daily basis.
Now, as part of the course curriculum, are they required to design their own product and deliver it at the end of the program?
Absolutely. Within our programs, we teach students both 2D design and 3D design using tools like AutoCAD and SolidWorks.
Right. Okay, so the difference between 2D and 3D design, describe that to us.
2D design is typically done when you want to cut out a shape in a piece of material.
Right.
3D design is when you want to create a model that can be sent to a machine like a 3D printer to actually build a full part.
Now, this is something that I've always been curious about. So basically, these machines prepare plastics, molds, to then turn into a fixed product. Is that correct? Or?
So the material is indeed plastic, and it comes on a roll. It's called a roll of filament. And then what the machine does is it takes the design model and it deposits the material in layers based on the design. So it basically puts the filament through a extruder head, which heats up the material and melts it, equivalent to a hot glue gun,
Yeah.
and then deposits it down based on the design. So it builds the model from the bottom up.
So do they end up being models, or do they end up being molds for injection molding machines, or is it
They
all
can
different?
be anything. They can be whatever you design it to be, right? So we have some examples here of some kind of artistic parts that people build on these machines. They can also be machine parts used in machines. We have another example here, which is actually it's a 3D scan of one of the people who actually works in the college here, and we create a model using a 3D scanner and then send that to the printer, and it creates the model. So it makes whatever you ask it to make.
For those of you who might be wondering, that's John Salaperto. That's hopefully, I think in the end, he's hoping for a bronze bust to be erected in the center of the quad here. Just kidding. So essentially, take me back to the way things were produced prior to this CAD design.
So this is really, there's a term used for 3D printing. It's called additive manufacturing. So it's actually, you're adding material to make the part. Traditional manufacturing has basically been, you take a block of material and you subtract from it, you cut from it. So it's really, it's a reverse process. Right?
I gotcha.
And one of the good things about this process is there's no wasted material, essentially, right? You're making the part that you want to make.
But when you produce that final product and it ends up being made of chromium or whatever, does it eventually go into that same kind of a machine, or is it? Do you know what I'm saying? If say you were building an engine block, you wouldn't design the block on a 3D printer, would you?
Well, so what a lot of companies do is when they take their initial prototype design, they will make it on a 3D printer to see if the dimensions are correct, if the shape is correct, if it fits with the other parts correctly. And the reason they do that is because it's much faster to create it on a 3D printer.
Sure.
So there are terms used in industry like rapid prototyping. So this saves time from the product life cycle so people can get their products to market earlier.
Right.
So they might make the initial prototypes on a 3D printer. Eventually they might tool it up and make it on a CNC machine or some other more expensive machine when they finalize the design.
Now, in the course here in the Fab Lab, do you also teach some of the disciplines involved with CNC, or is that a whole other?
We have a couple of mini milling machines here, so students can create, it's called G-code, CNC code, to make stuff on our smaller milling machines here. The idea of the equipment here is it's a little bit more accessible than some of the bigger machines that are up in our advanced manufacturing lab. It's
Sure.
a little less intimidating.
Right. Right, and again, it's teaching you the nomenclature and the basic skills involved in the whole industry evolved to date, I guess is what it is.
Absolutely.
And it's changing all the time too, is it
Yep.
not?
It is, and we're trying to stay, we've bought a couple of new 3D printers, which is a slightly different technology. So we're trying to keep up with all of the changes in the technology.
Right. And a few minutes ago, you also mentioned the fact that you're doing your best to, create a surplus of students for the jobs currently in Central Massachusetts. Are there a lot of businesses that are looking for these kind of employees?
There absolutely are. We have a lot of companies that we speak to regularly, and I think every one of those companies is in hiring mode right now. So we have new job opportunities come across our desk all the time. Our challenge is to get enough people into our program and out of our program to meet those needs.
Right. Is there an opportunity to actually gain employment at some of these companies while they're going to school?
Absolutely. So one of the key elements of our programs is a co-op program where students are placed in these companies and they develop relationships, and sometimes that relationship leads to a full-time position. So absolutely.
Right, right. Well, that's great. We are talking with Damian Kieran, of the Associate Professor of Manufacturing Technology here in the Fab Lab at QCC, which is obviously the Quest Center. How have the students reacted coming into a beautiful new facility like this?
Well, it's funny, the new students don't realize how lucky they've got it.
Sure.
The students who've been here for a few years are thrilled because, they saw what we had before versus what we have now, and it's really, we're now state of the art. We had a good program before, but we were limited by space and by the new equipment we could buy because we didn't have space. Now with all this space and all this new equipment, we've really become state of the art.
Great. When QCC's Face the Region continues here in a couple of minutes, we'll sort of explore some of the other machinery and high-tech gear you'll find here in the Fab Lab as Face the Region continues on Full Service Radio, AM 830 WCRN. We'll be right back. Welcome back to QCC's Face the Region here on Full Service Radio, AM 830 WCRN. Once again, coming to you from the Quest Center at QCC, and more specifically, the QCC Fab Lab with Damian Kieran, the Associate Professor of Manufacturing Technology, which, as we have learned in the past few minutes, just how exciting and really cutting edge the equipment is here at the Fab Lab. Now, you had mentioned that there's access for any students who are interested in creating something. They don't necessarily have to be part of your class.
Right. So we do run some manufacturing classes in here, and we do some manufacturing specific projects in here. But we are open every day for a few hours for open access for all students and all staff and faculty in the college.
And the only requirement being that they must bring their own design and immerse themselves.
The only requirement is that they have some interest and be prepared to put in a little bit of effort to create something and have an idea. We can help them create the designs. We can show them how to do that work. But we want to get them in here so they can see what's possible in here.
Great. What a great opportunity that is. Have you seen some pretty cool designs come through here with both folks in your course and just students attending otherwise?
Yeah, so a few examples are we did a pretty big project here in the spring, which was we actually built our own 3D printers. We built a couple of printers. So that required purchasing 700 or 800 parts per machine. It required a lot of blood, sweat, and tears on the part of the students putting it together and troubleshooting, getting the software running. So that was a big project that we did here. But we've had some smaller projects. We had a student come in here yesterday with an issue with an old vintage bicycle that they needed to fix, and they were able to accomplish that in here. We've had a student who had a broken fastener on his backpack, and he was able to scan that fastener and actually 3D print a replacement. So some cool stuff.
And what's that you've got there sitting on your knee?
So a brand new piece of equipment is behind us here. It's a custom embroidery machine, which again requires students to create a design and send it to the machine and troubleshoot it. But we can do stuff on here like custom embroidery on hats, on shirts, on any piece of clothing, we've done this one on a bag here. So what we're trying to do is to have some hooks and some encouragement for students to come in. It's not just about cutting metal and cutting plastic.
Now you had mentioned that not many Fab Labs have this type of a machine.
We've been lucky here. We got some additional funding, so we have some equipment here, like the embroidery machine, that's above and beyond what a typical Fab Lab would have. But again, it's still in the vein of you've got to design something and you've got to translate that design into a program that runs on a machine. So it is manufacturing.
Right, but such valuable.
Kind of cool manufacturing.
Yeah, valuable, hands-on, cool experience. Seems like you have quite a passion for this. How did you get started?
So my background is in supply chain and manufacturing engineering. I worked for a bunch of high-tech companies like Digital, EMC, a company called 3Com. Then I also worked in medical devices for Boston Scientific for a couple of years.
Wow,
So
yeah.
this has been my life's work, I guess. I've been working here at QCC for 4 or 5 years now, and what I'm trying to do is, share some of what I've learned along the way with the students.
As a young person, a young guy, when did the bug bite you about figuring out how things worked?
I think I was always interested in messing around with cars and stuff like that. So, and I had older brothers who messed around with cars, so that was part of it, I think. Also, honestly, at the time, I realized it was a pretty good way to make sure I got a job when I came out of college. So there was that element of it too, and that still applies.
Well, and the beauty of that is, as they say, if you're doing something you love, it's not work. It's what you love.
Right, and you're making cool stuff. Making medical devices. You're part of affecting people's lives and making people's lives better. So
I know this is kind of a tough question, but decent salaries to somebody graduating with this type of a background?
absolutely, and in the current environment where there's a shortage of qualified people, when there's a shortage of people, salaries go up. So decent salaries and really good development prospects. There's a lot of growth at these companies. We have an aging population of people who work in this field, and they're starting to retire now. So there's plenty of room for growth for people coming through this field.
And again, you see it evolving day to day. I mean, I would imagine that I can just tell in the electronics that I deal with, it's every week it's something cutting edge.
Absolutely, and our goal here is to stay on that cutting edge curve.
So if you were talking to say a potential student in high school, what would what would they do to get involved in this program, and what should they be taking now if they had an opportunity to take courses related?
Well, they don't really have to take anything beyond the standard courses. If they have an opportunity to do a CAD course or some kind of machining course or something like that at their high school, that would be obviously awesome. But they don't need to do anything special. What I would say to them is, come in and see us and see what we've got here. And it'll probably change your perception of manufacturing and get you a lot more interested in it.
And make your own hat.
Absolutely.
With your
Absolutely.
own name, or perhaps your own bronze bust in the case of John Saliperto. That's great. Damian, it's been a really interesting half hour. I know if I was of that inkling, I'd certainly be in here in a regular business, just on basis, just tinkering around. But continued success, and we'll see you again. Next time around, I'm sure you'll have something new to show us.
Appreciate that. Yeah, you're welcome anytime.
There you go. Thank you, Damian. Once again, the Fab Lab at the Quest Center, home of all the STEM programs here at Quinsigamond Community College. That'll do it for this edition of Face the Region. Join us again next week at the same time right here on Full Service Radio, AM 830 WCRN.
This has been Quinsigamond Community College's Face the Region. Join us again next weekend on AM 830 WCRN.